try creating a similar database with SQLAlcemy. SQLAlcemy will not create our database, only connect to it. So let's quickly initialize something with the MySQL shell. I'll type in MySQL -u root -p, and we'll put in the password of MySQL. So this is what you configured when you installed MySQL, and we're in. To create a database, we'll write create database, and we're going to call this one household. To get out of the shell, we'll go \q, and we're out. Let's clear this up. Before we get started, let's create a virtual environment to work in. We'll need to install the MySQL connector as well as SQLAlcemy in this environment. So I'm going to go virtual env. I'm going to call this MySQL SQLAlcemy workspace. I'm going to cd into it and then activate the workspace. From here, I'm going to install the MySQL connector as well as SQLAlcemy. So I'll go pip3 MySQL connector, Python, and then pip3 install SQLAlcemy. Great. Now let's connect to our database using SQLAlcemy. We'll do that from a Python file. We'll be using the ORM components of SQLAlcemy in this chapter, so it'll look a little bit different from what we did with SQLAlcemy Core in the last chapter. Whether you are using SQLAlcemy Core or SQLAlcemy ORM, both will work for MySQL and SQLite, as well as any other supported relational database management systems. In our Python file, we'll first need to import some data types from SQLAlcemy, as well as the ability to connect to the database using Create Engine. So I'll write from SQLAlcemy, and we'll put in a few data types here, the column, the idea of an integer, a string, a foreign key. We'll use these later on, and then Create Engine as well. We'll put that on a separate line. We're also going to import a session maker and relationship from ORM. We will use these later on and talk about them when we get to them in the Python file. Same thing for declarative base. Now let's connect to our database. The syntax here is the database type along with the driver. So we're going to be using the create engine function, the database type, which is MySQL, and the driver, which is MySQL connector. Remember, with SQLite, we did not need a driver because the database was not on a server. From here, we'll give it our user and password, which is root. My password is password, but you'd put in whatever your password is for MySQL here. And then we'll do @localhost. This is the host for our database, and by default, it's at port 3306. Then to connect to a specific database, we'll go /household. That's the database we just created. Another parameter we'll add is echo equals true. This will make SQLAlcemy print out SQL statements that it executes. This can be useful when you want to understand what's going on behind the scenes with SQLAlcemy. We'll save this engine in a variable called engine. From here, instead of grabbing the cursor and executing statements, we can create classes and models for the records and objects our database will hold. In this section, we'll be diving into the ORM side with object relational mapping. This will make interacting with our database more Pythonic. All models in SQLAlcemy are based on the declarative base. So we'll create a base with the function declarative base. And we'll save this in a variable called base. With this base, we can begin to create our models for our corresponding project and task tables. The data in this database, this household database, will be pretty similar to what we just did with the MySQL connector. Starting off with the project model, we'll go class project. We're going to base it off of the base. And we're going to set a few attributes about the table. That include the table name, which will be projects, as well as some table args. This will include the schema and the fact that it's in the household database. Now we set up the columns. Just like the last database we created, this table will have a project ID, title, and description. Let's talk about these columns. Column, integer, and string were imported above. The project ID column will have that integer data type and be the primary key for this table. The title will be a string and contain text data of up to 50 characters. This is also true of the description, but we could make this bigger if we wanted to. Next, we'll write a function to show a printable representation of this object. This is like a toString function. Awesome. Our first model is done. Now onto the task model. We'll write class task. It'll also be based on the base, and we'll give ourselves some room here. The table name will be tasks, and it'll have the same table args as the project, so this will organize them together. This is important because we'll have a foreign key relationship. For the columns, we'll have task ID, project ID, and description. As with the project table, we have a primary key, that's our task ID, and the project ID in the task table will link as a foreign key to the primary key of the project table, which is also project ID. We use the name of the database, the name of the table, and then the name of the appropriate column to connect with. To further define this foreign key relationship, we're also going to write project equal relationship, and this has a relationship with the project table. Notice we use project, the name of the class, and not the name of the table here. Relationships are important with SQLAlcemy because they complement foreign keys. They tell our application that we're building relationships between two models rather than the database. The foreign key implementation inside the column definition references the database's tables and syntax, but the relationship references our model in SQLAlcemy. To connect everything together, we need to do both. This may seem like a lot, but this helps us easily perform joins in our app, since project data and task data are very related, and it's often we'll want to see tasks that correspond with a given project. This defines the relationship up front, so we can easily work with it in our app's business logic, which we'll see in a minute. Similar to the projects model, we'll write a printable format for the task. With our models in place, we can create all of the corresponding tables in SQL with base.metadata.createAll and pass in the engine. So here we're using the base from declarative base as well as the engine we created before. It's connecting it to MySQL on our machine, on localhost. For the createAll function, if the tables already exist, then SQLAlcemy will use the already existing table rather than creating new tables. Let's run this program. I'm going to clear up our terminal. And before you run your Python application, make sure your workspace is activated. This is where you've installed MySQL connector as well as SQLAlcemy. I'm going to run an ls, and there's our Python file. We'll run it with the Python 3, MySQL, and see what happens. Whoa, that's a lot of statements. These are the actual SQL queries being run with SQLAlcemy, which is pretty cool. They look a lot like what we did manually in the previous lessons. Now, it's all automated.